Our objective in this lesson is to express rational numbers from fraction form to decimal form and vice versa. Let's have a quick review of our previous lesson. Identify the blue bold numbers and tell what property is illustrated. Number 1, 9 plus 0 is equal to 9. 0 here is what we call additive identity or identity element for addition. And the property illustrated here is identity property for addition. Negative 8 here is what we call additive inverse. The sum is equal to 0. This property is inverse property for addition. 1 over 10 here is what we call multiplicative inverse or reciprocal. 1 is the answer. And this property is inverse property for multiplication. 1 here is what we call multiplicative identity or identity element for multiplication. And the property illustrated here is identity property for multiplication. Do you still remember the place value chart? From the decimal point going to the left is the whole number part. We have the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. From the decimal point going to the right is the fractional part. We have the tenths, hundreds, thousands, 10,000s, 100,000s, and millions. Let's have a quick activity. What's my equivalent? Let us supply the missing equivalent in each row. This is 3 tenths. In fraction, this is 3 over 10. This one is 3 hundredths. In decimal form, this is 0.03. This one is 5 and what is the place value of 3 here? We have the tenths, hundredths, thousands. So this is 5 and 3 thousandths. Fraction to decimal form. Here are some things that you need to remember. The number of decimal places tells us the denominator of the fraction. If it is 1, the denominator is 10. If it is 2, the denominator is 100. One place to the right of the decimal point has a value of tenths. It denotes a fraction whose denominator is 10. The number of zeros in the denominator of a fraction is the same as the number of decimal places in its decimal form. Let's have an example. Let us convert 3 over 10 to decimal form. Step 1. Find a number you can multiply by the denominator to make it 10, 100, or 1000, or any one followed by zeros. Since our denominator is already 10, then we'll just have to copy it. Step 2. Multiply both numerator and denominator by that number. Again, since our denominator is already 10 and we did not multiply any number to make it 10, then let us just copy the given. Step 3. Write down the numerator. So let us write 3, putting the decimal point in the correct spot. Initially, the decimal point is on the right of 3. Now, where is the correct spot? It is one space going to the left for every zero in the denominator. How many zeros do we have here in our denominator? We only have 1. So that means one space going to the left. So the decimal point will be placed here. And last step, if there is no number on the left of the decimal point, add 0 in front of the decimal point. Since there is no number here, then we're going to add 0. This is how to write it properly. So 3 over 10 is equal to 0.3. Let's have another one. Step 1. Find a number you can multiply to the denominator to make it 10 or 100 or 1000 or any one followed by zeros. We can multiply 5 by 2 to make it 10. Step 2. Multiply both numerator and denominator by that number. Let us copy our fraction and let us multiply both numerator and denominator by this number. So we have times 2 over 2. 1 times 2 is equal to 2. 5 times 2 is equal to 10. Step 3. Write down the numerator. Our numerator is 2 and initially the decimal point is here. Let us put it in the correct spot. Again, we only have one zero in our denominator, so that would be one space going to the left. The decimal point should be here. And let us put 0 in front of the decimal point because there is no number here. So 1 over 5 is equal to 0.2. Another one, step 1, we can multiply 20 by 5 to make it 100. Step 2, multiply both numerator and denominator by that number. Let us copy our fraction. Multiply this by 5 over 5. 7 times 5 is 35. 20 times 5 is equal to 100. Step 3, let us write down our numerator. The decimal point is initially here. Let us put it in the correct spot. Let us count the number of zeros in our denominator. We have 1, 2. So 2 spaces going to the left. 1, 2. Decimal point should be here. And let us place 0 in front of the decimal point. So 7 divided by 20 is equal to 0.35. Another one. Step 1 again. We can multiply 4 by 25 to make it 100. Step 2. Multiply both numerator and denominator by that number. 7 times 25 is equal to 175. 4 times 25 is equal to 100. Step 3, let us write down our numerator. The decimal point is initially here, and let us put it in the correct spot. Let us count the number of zeros in our denominator. We have 1, 2. So let us move 2 places going to the left. 1, 2. So the decimal point should be between 1 and 7. And since we have a number in front of the decimal point, there's no need to write 0. So 7 divided by 4 is equal to 1.75. Last one. Again, let us find a number that we can multiply by the denominator to make it 10, 100, or 1000, or any one followed by zeros. Unfortunately, we cannot find a number that will do that. What we will do is to find a number that we can multiply by 9 to make it closest to 10, 100, 1000, or any one followed by zeros. So I can multiply 9 by 11 to make it 99. This is the closest number to 100. Step 2, multiply both numerator and denominator by this number. 4 times 11 is 44. 9 times 11 is 99. Step 3, let us write down our numerator. The initial position of the decimal point is on the right of the number. Since there is no zeros in our denominator, but this is closest to 100, and 100 has 2 zeros, then we are going to move the decimal point 2 places going to the left. So the decimal point should be here. And since there is no number in front of the decimal point, we are going to add 0. So 4 over 9 is equal to 0.44. But this is only accurate up to 2 decimal places only. Because remember that we only find a number that is closest to 100 but not exactly 100. There is another way of converting fraction to decimal form, and that is by long division. Let us copy 1 divided by 2. Since we cannot exactly divide 1 by 2, we're going to add zero point 0. Remember, 1 is just equal to 1.0 or 1.00 or 1.0000. Now, it looks like we have a 10. Just ignore first the decimal point here. So 10 divided by 2, and that is equal to 5. Now, don't forget to write the decimal point. Align it here with this decimal point here. So we'll put decimal point here. 5 times 2 is equal to 10. Let us subtract. 10 minus 10 is equal to 0. That is our objective, to make this equal to 0. Since, again, there is no number in front of the decimal point, we're going to add 0. So 1 over 2 is equal to 0.5. Let's have another example. 5 divided by 4. So copy 5 divided by 4. Can we form a 4 in 5? Yes, we can. How many 4 can we form in 5? Just 1. So we'll put 1 on top of 5. Then 1 times 4 is equal to 4. Let us subtract. 5 minus 4 is equal to 1. Now, we cannot divide 1 by 4. So, we're going to add 0.0. Again, 5 is just equal to 5.0. Then, let's bring down this 0 here. So, now we have 10. 10 divided by 4 is equal to 2. Oops, don't forget the decimal point. Let's put it here. Then 2 times 4 is equal to 8. Let us subtract this. 10 minus 8 is equal to 2. It is not yet 0, so let us add again another 0 here. Let's bring it down here. So we have 20. 20 divided by 4 is equal to 5. 5 times 4 is equal to 20. Let us subtract this. 20 minus 20 is equal to 0. So, we are done. 5 divided by 4 is equal to 1.25. Let us have another one. 4 divided by 9. Since 4 is less than 9, let us add zero point 0. Now we have 40. How many nines can we form in 40? We can form 4 nines. Oops, don't forget the decimal point. Let's align it here. Then 4 times 9 is equal to 36. Let us subtract this. 40 minus 36 is equal to 4. Let's add another 0 here. Let's bring it down. So we have 40. 40 divided by 9 is 4. 4 times 9 is equal to 36. Let us subtract. 40 minus 36 is equal to 4. Can you see a pattern here? 40, 36, 40, 36. Then this 4 will become 40 again. So we'll have 36 and then another 4. This process will never end. So as our answer, 4, 4, 4, 4, 4, 4. To describe that, we are going to make use of a symbol. We're going to put a horizontal bar on top of 4. This symbol is what we call vinculum. It means 4 here will repeat forever. Since there is no number in front of the decimal point, so let us add 0. So 4 divided by 9 is equal to 0.4. So 4 here again will repeat forever. This is an example of non-terminating repeating decimal. Let's have the last one. 9 divided by 11. Since 9 is less than 11, let us add zero point 0. Now we have 90. How many 11s can we form in 90? We can form 8 11s. Oops, don't forget the decimal point. 8 times 11 is 88. Let us subtract. 90 minus 88 is equal to 2. Let us put 0 here. Let's bring it down. So we have 20. 20 divided by 11 is just 1. 1 times 11 is 11. Let us subtract. 20 minus 11 is equal to 9. Let us add another 0 here. Let's bring it down. So this will become 90. 90 divided by 11 is equal to 8. 8 times 11 is 88. Let us subtract. 90 minus 88 is equal to 2. Can you see again a pattern? 90, 88, 20, 11, 90, 88. Then this will become again 20. Then you'll have 11. Then you'll have 90 again. So this process again will never end. Now, let's take a look at our answer. 818. So the numbers were repeated after two decimal numbers. So we're going to write our vinculum on top of 8 and 1. This means that 81 will repeat forever. Since there is no number in front of the decimal point, we're going to add 0. So 9 divided by 11 is equal to 0.818181818181. Again, this is an example of non-terminating repeating decimals. Now let us convert decimals to fractions. Step 1. Write down the decimal number divided by 1. So we have 0.75 divided by 1. Step 2. Multiply both numerator and denominator by 1 followed by zeros. The number of zeros depends on how many numbers are there to the right of the decimal point. Here is the decimal point. Let us count the numbers to the right of it. We have 1, 2. So it means we're going to multiply this by 1 followed by 2 zeros. That is 100. We're going to do the same thing in the denominator. So 0.75 times 100. Since we have 2 zeros here, this decimal point here will move 2 places going to the right. So this is equal to 75. And 1 times 100 is equal to 100. Step 3, simplify or reduce the fraction to its lowest term. And how are we going to do that? Using the greatest common factor, GCF. Let's have a quick review. Our first number is 75. All we have to do is to express 75 into its prime factors. 75 is 5 times 15. 15 is 5 times 3. 5 and 3 are both prime factors. How many 5s do we have here? 2. So that means 5 is squared. And then 1, 3. So 75 is equal to 5 is squared times 3. We have two 5s. 1, 2. That is 5 squared. And then another prime factor is 3. So we're going to multiply it with 3. The second number we have is 100. 100 is 5 times 20. 20 is 5 times 4. 4 is 2 times 2. 5 and 2 are both prime numbers. So how many 5s do we have here? 2. How many 2s do we have here? 2 also. So 100 is equal to 5 squared times 2 squared. Here it is. 1, 2, 5 squared. 1, 2, 2 squared. Now, how do we determine the GCF? Greatest common. Their common factor is 5. Here, 5 and 5. That is their common factor. Since both of them have 5 squared, then that is their common factor. 5 squared, which is equal to 25. So our GCF is equal to 25. So let us copy 75 over 100 and then let us divide both numerator and denominator by the GCF. 75 divided by 25 is equal to 3. 100 divided by 25 is equal to 4. So 0.75 is equal to 3 over 4. Let's have another one, 0.625. Again, step 1, write down the decimal number divided by 1. Step 2, multiply both numerator and denominator by 1 followed by zeros. Let us count how many numbers do we have on the right of the decimal point. We have 1, 2, 3. So we're going to multiply this by 1 followed by 3 zeros. That is 1,000. We're going to do the same thing in the denominator. 0.625 times 1,000. Since we have 3 zeros here, this decimal point will move 3 spaces going to the right. We have 1, 2, 3. So 625. Actually, that is the idea. We multiply it with the corresponding number of zeros to make the decimal number a whole number. Then 1 times 1,000 is equal to 1,000. Step 3, let us simplify this to its lowest term. There is another way of reducing this to its lowest term without doing the GCF. So let us copy 625 divided by 1,000. Now, you think of a number where you can divide both 625 and 1,000. And that could be 25. 625 divided by 25 is 25. 1,000 divided by 25 is 40. Now, analyze your answer. Is there a number that you can divide both 25 and 40? Yes, there is, and that is 5. So 25 divided by 5 is equal to 5. 40 divided by 5 is equal to 8. Analyze your answer again. Is there a number where you can divide both 5 and 8? None. So meaning this is your final answer. So 0.625 is equal to 5 over 8. Another one, we have 5.4. Notice that we have here a whole number, 5. We'll just set it aside. We'll put it back later at the end. So let us write down our decimal number divided by 1. Let us multiply both numerator and denominator by 1 followed by zeros. Let us count the number after the decimal point and we only have 1. So we're going to multiply this by 1 followed by 1 zero. That is 10. We'll do the same thing in the denominator. Again, the idea of doing this is to make the decimal number a whole number. So this will be equal to 4. And 1 times 10 is equal to 10. Now let us simplify this. Let us copy 4 over 10. Think of a number wherein you can divide both 4 and 10. That would be 2. 4 divided by 2 is equal to 2. 10 divided by 2 is equal to 5. Is there a number that you can divide both 2 and 5? None. So this is our final answer for the decimal number. So let us put back 5 and then we have 2 over 5 for 0.4. So 5.4 is equal to 5 and 2 over 5. This is a mixed number, a combination of a whole number and a fraction. If we want to convert this into improper fraction, we're just going to multiply this two number here and then the product will add it here in the numerator. So this will be equal to 5 times 5 is 25 plus 2 is 27 and then copy the denominator. So 27 over 5. Another one, 0.33. Notice these three dots here. This is called ellipsis. It means 333 will never stop. It will keep on going forever. Step 1, let x be equal to the decimal number. So x is equal to 0.33333. This will be our equation 1. Step 2, count the length of repeating decimal. When I say length of repeating decimal, you count how many numbers before the decimal was repeated. So in here, after the first number 3, it is already repeated. So the length of the repeating decimal is only 1. Multiply both sides by 1 followed by zeros. The number of zeros depends on the length of the repeating decimal. So again, the length of our repeating decimal here is just 1. So that means we're going to multiply both sides by 1 followed by 1 zero. So that is 10. So 10 times x is 10x. And then 0.33333 times 10 will be equal to 3.33333. This is now our equation 2. Step 3, subtract equation 1 from equation 2. So our equation 1 is the first one and the equation 2 is the second one. We're going to subtract the first one from the second one. I'll copy the second one and then I'll subtract the first one. So 10x minus x is equal to 9x. 3.3333 minus 0.333. 0.333 here will just cancel out. So we have 3 minus 0 is equal to 3. And then let us solve for x. To solve for x, we're going to divide both sides by 9. So 9 here will cancel out. So we have x is equal to 3 over 9. Think of a number where you can divide both 3 and 9, and that would be 3. 3 divided by 3 is equal to 1. 9 divided by 3 is equal to 3. Is there any number that you can divide both 1 and 3 again? None. So this is our final answer. So 0.3333 is equal to 1 over 3. 0.33 here is an example of non-terminating repeating decimal. Let's have another one. This time we have 0.575757 and it will keep on repeating forever. So step 1, let us let x be equal to our decimal number. This is our equation 1. And then let us count the length of the repeating decimal. So we have 5, 7, and then 5, 7, 5, 7. So the numbers were repeated after two decimal numbers. So the length of the repeating decimal here is 2. So we're going to multiply both sides by 1 followed by 2 zeros. Because the length of the repeating decimal is 2, so multiply it by 1 followed by 2 zeros. That is 100. So 100 times x is 100x, and 0.575757 times 100 will be equal to 57.57. The decimal point here will just move 2 places going to the right, so it becomes 57.57. This is our equation 2. Next step, let us subtract equation 1 from equation 2. So 100x minus x is equal to 99x. 57.57575757 minus 0.57575757. This 0.575757 here will just cancel out. 57 minus 0 is equal to 57. Now let us solve for x. And to do that, we're going to divide both sides by 99. So 99 here will just cancel out. So we have x is equal to 57 over 99. Now think of a number wherein you can divide both 57 and 99. That would be 3. 57 divided by 3 is equal to 19. 99 divided by 3 is equal to 33. Again, analyze your answer. Is there a number wherein you can divide both 19 and 33? There is none. So this is our final answer. So 0.57, 57, 57, and so on is equal to 19 over 33. Again, this is an example of non-terminating, repeating decimals. Let us try this. Convert the following to decimal form. Round off your answers into hundredths place. Number 1, 7 over 9. So we have 7 divided by 9. Since 7 is less than 9, let's add zero point 0 here. So we have 70. 70 divided by 9. How many 9s can we form in 70? We can form 7 9s in 70. Don't forget the decimal point. 7 times 9 is 63. Let us subtract. 70 minus 63 is equal to 7. Let's add 0 here. Let us bring it down. So we have 70. 70 divided by 9 again is 7. 7 times 9 is 63. Let us subtract. 70 minus 63 is equal to 7. So there is a repeating process here. Since we are asked to round off our answers into hundredths place, we are going to put our vinculum from the tenths place to the hundredths place. Since there is no number in front of the decimal point, we're going to add 0. So 7 divided by 9 is equal to 0.777777. Non-terminating, repeating decimals. Number 2, we have 5 divided by 28. Since 5 is less than 28, let us add zero point 0. So we have 50 divided by 28. We can form 128 in 50. Don't forget the decimal point. 1 times 28 is equal to 28. Let us subtract. 50 minus 28 is equal to 22. Since this is only 22, let us add another 0 here and let us bring it down. So we have 220. 220 divided by 28, we can form 728 in 220. 7 times 28 is 196. Let us subtract. 220 minus 196 is equal to 24. 24 is less than 28. Let us add again another 0. Let us bring it down. We have 240. How many 28 can we form in 240? We can form 8 28s. 8 times 28 is equal to 224. Let us subtract. 240 minus 224 is equal to 16. There is no pattern here, but this process will never stop. We are asked to round off our answers to hundredths place. And since 8 is greater than 5, then we're going to round up 7. But first, let us add 0 in front of the decimal point. So 5 divided by 28 is equal to 0.18. Again, 8 is greater than 5, so we're going to add 1 to 7. It becomes 0.18. Last one, 33 divided by 4. Since 33 is greater than 4, it means we can divide 33 by 4. How many 4s can we form in 33? We can form 8 4s. 8 times 4 is 32. 33 minus 32 is equal to 1. Let us add zero point 0 here. Let us bring down 0. This will become 10. 10 divided by 4 is equal to 2. Don't forget the decimal point here. 2 times 4 is equal to 8. Let us subtract. 10 minus 8 is equal to 2. Let us add again another 0 here. Let's bring it down. This will become 20. 20 divided by 4 is equal to 5. 5 times 4 is equal to 20. Let us subtract. 20 minus 20 is equal to 0. So we have a terminating decimal here. 33 divided by 4 is equal to 8.25. Now let us try this. Convert the following to fraction. Express your answers in simplest form. Number 1, this will become 0.27 divided by 1. Since there are two decimal numbers here, we're going to multiply our fraction by 100. Two zeros. 0.27 times 100 will become 27. 1 times 100 is 100. Think of a number wherein you can divide both 27 and 100. There is none. So 0.27 is equal to 27 divided by 100. Number 2, this will become 7.8 divided by 1. Since there is only one decimal number, we're going to multiply our fraction by 10. 7.8 times 10 will become 78. 1 times 10 will become 10. Now, think of a number wherein you can divide both 78 and 10. And that is 2. 78 divided by 2 is 39. 10 divided by 2 is 5. Think again of a number wherein you can divide 39 and 5, but there is none. So 7.8 is equal to 39 over 5. Last one, 7.44444. So let us let x be equal to 0.4444. Let us ignore first the 7 here. We're going to put it back later at the end. This is our equation 1. Let us multiply both sides by 100. 100 times x is 100x. 0.44444 times 100 will become 44.44444. This is now our equation 2. Let us subtract equation 1 from equation 2. So this will become 100x minus x is 99x. 44.444 minus 0.444. 0.444 here will just cancel out. So we have 44 minus 0 is equal to 44. Let us divide both sides by 99. So 99 here will cancel out. So we have x is equal to 44 over 99. Think of a number wherein we can divide both 44 and 99, and that is 11. 44 divided by 11 is equal to 4. 99 divided by 11 is equal to 9. Let us bring back the whole number, that is 7. And the counterpart of 0.44 is 4 over 9. You can also express this into improper fraction. Just multiply 7 times 9, that is 63, plus 4 is 67, and then copy the denominator. 67 divided by 9. Let us do extra challenge. Number 1, the distance from the house of Georgie to her school is 0.86 kilometer. What is its equivalent in fraction form? So we have 0.86. We're going to divide this by 1. Since there are two decimal numbers here, we're going to multiply our fraction by 100. 0.86 times 100 will become 86. 1 times 100 is 100. Think of a number wherein we can divide 86 and 100, and that would be 2. 86 divided by 2 is equal to 43. 100 divided by 2 is equal to 50. Now think of a number again wherein you can divide both 43 and 50. There is none. Therefore, 0.86 is equal to 43 over 50. Number 2, MJ received the result of her exam. It is marked 38 over 50. What's her mark in decimal? 38 over 50. We can still express this in lowest term. Let's do that. Think of a number wherein you can divide both 38 and 50. That would be 2. 38 divided by 2 is 19. 50 divided by 2 is 25. Remember to express the given number into lowest term if possible before converting it into decimal. So we have 19 divided by 25. Since 19 is less than 25, let us add zero point 0 here. We have 190. 190 divided by 25 is 7. Don't forget the decimal point. 7 times 25 is 175. Let us subtract. 190 minus 175 is equal to 15. 15 is less than 25, so let us add 0 here. Let's bring it down. This will become 150. 150 divided by 25 is equal to 6. 6 times 25 is 150. Let us subtract 150 minus 150 is equal to 0. We have a terminating decimal here. Since there is no number in front of the decimal point, let us add 0. So 38 over 50 is equal to 0.76. For the summary, here are the steps of converting fraction to decimal form and decimal form to fraction. Now it is time to check your understanding. Pause this video for more time. Let us answer. Let us convert 11 over 15 to decimal form. So 11 divided by 15. Since 11 is less than 15, let us add zero point 0 here. We have 110. How many 15s can we form in 110? We can form 7. Do not forget the decimal point. 7 times 15 is equal to 105. Let us subtract. 110 minus 105 is equal to 5. 5 is less than 15. Let us add again another 0. Let's bring it down. This will become 50. 50 divided by 15 is equal to 3. 3 times 15 is equal to 45. Let us subtract. 50 minus 45 is equal to 5. 5 is less than 15. Let us add again another 0. Let's bring it down. This will become 50. So 50 divided by 15, that would be 3 again. So 3 times 15 is 45. Let us subtract. 50 minus 45 is equal to 5. I can see a pattern here. This will again become 50. Then you can form again 3 here and then 45, another 5. So this means 3 here will keep on repeating. Since there is no number in front of the decimal point, let's add 0. So 11 divided by 15 is equal to 0.733333333 and so on. Notice that I only put the vinculum on top of 3 because 3 is the repeated number, not including 7. So you're going to put the vinculum on top of the repeating number. Now let us convert 0.72 into fraction. So let us express this as 0.72 divided by 1. Since there are two decimal numbers, we're going to multiply the numerator by 100 as well as the denominator. 0.72 times 100 is 72. And 1 times 100 is 100. Think of a number wherein you can divide both 72 and 100. That would be 2. 72 divided by 2 is 36. 100 divided by 2 is 50. Analyze again. Think of a number wherein you can divide both 36 and 50. Again, I can divide this by 2. 36 divided by 2 is 18. 50 divided by 2 is 25. Is there any number wherein I can divide both of this? No more. Therefore, 0.72 is equal to 18 over 25. Gets? Our next lesson is operations on rational numbers.